Okay, so hi everyone. My name is Łukasz Pięta. I work at Stepwise, and the topic of my today's presentation is design patterns revisited in Kotlin. So why this topic? I've been programming in Kotlin on the server side for almost 5 years right now, and I've observed many people transiting from Java to Kotlin, and I've seen many patterns in Java which are kind of a standard of our community, the way we write code. In Kotlin, they are not actually fully transitive because Kotlin has some features that we don't have in Java, and that's why I wanted to show you some design patterns that in Kotlin should be implemented in a little bit different way. And as you can see here, there's singleton, builder, factory function, and decorator pattern. And there are two more which are not the classic design patterns itself, null safety and pipe operator. And I wanted to mention them too because null safety makes a huge difference between Java and Kotlin, the way you're thinking of writing the code. And the pipe operator, maybe it's not considered as a design pattern itself, but because Kotlin is a multi-paradigm programming language, it's very important to have this functional way of thinking in some cases, and I want to show you these two design patterns too. So let's start from singleton. So I guess most of you know what singleton is, that we want to make sure that there's just one instance of something, of a class, and in Java it would look like this. So it's a dummy implementation, right, because it's not thread safe, etc. But basically, that's the idea in Java. When we do it in Kotlin, it's just two words, because we have a keyword object that is responsible for creating a singleton for us. So Kotlin takes the responsibility of making things right. And if you're not sure if Kotlin does it right, you can always check the decompiled code and see the actual implementation in Java bytecode. So as you can see, it's not much different from what I did 2 slides before, but here we've got this static code block which makes sure that these instructions will be executed just on the class loading, so it will be executed just once. And that's all about singleton. In Kotlin, you don't need to write your own implementation. And you can, of course, treat this object class actually as a class. You can add methods to it. You can control the moment it's been initialized by init block method. So you can do much stuff there. It's not like it's the object and it's got some limitations because of that. The next one I'd like to talk about is null safety. And as I said, that's the huge difference between Kotlin and Java, because in Java there's no null safety. You can write this and it compiles, but it throws a null pointer exception in the runtime. So there's no null safety in Java. And someone says, okay, you've got optional, you've got a wrapper to control the flow better. And you probably use this in Java because it's all you've got. But there's a case in which optional can be null too. So actually it doesn't help, because there is still null pointer exception thrown when we try to invoke this method is present, or I don't know, try to get to any member value or whatsoever, right? So I feel like when Java developer tells me there's null safety in Java, it's like, you know, he's lying to me, right? Because there's no null safety. And on the other hand, we have Kotlin, and Kotlin guarantees in a compilation time that the thing that we know it's non-nullable will stay non-nullable, because compiler is our friend. And at the first code snippet, you can see that code like this won't compile in Kotlin. It would have in Java, right? Kotlin says, hey, you cannot just get access to length member of some nullable type because it's nullable type, right? You need to do it safely. So the way you can do it with if statement, you can do it using scope functions in Kotlin. So these two code snippets are just examples of how to avoid null, how to handle it properly. And you might wonder, okay, I'm a good developer. I write in Java, I don't know, for 12 years, right? Someone can say it. And I write perfect code. I know how to control nulls. They won't happen in my application. Google also has great developers, doesn't it? And Google transited from Java to Kotlin, and they observed 20% less likely application to crash. So that's some metric. You can actually go to your manager and say, hey, we need to write in Kotlin. Why? Look at this metric. And that's something you can talk to business with, right? Because that's a metric that business might like. But the problem is when the null safety is used in the wrong way, because code like this is even worse than Java with no null safety, because now everything can be null, and it's not like in Java that we need to make these if statements only if we remember to do them, because compiler won't let us do something on non-nullable types, if we want them to be non-null. So what you do now is making all these question marks to get to the value which will not be null, and it's a mess in your code. What's even the point of nullable list, right? If there's a null, why isn't it empty list? I know there are some business cases in which this null is value, but if we make everything nullable as default, we miss this business information. And if we'd like to find where is this business information, we are new to the project and we see this, we don't know anything. So the tip from me here is to define the contract the way Kotlin does. When you look into their functions in the standard library, you can see that they don't only define the types as nullable or not, they also change the functions names. So it's explicitly defined that some function will return a result or will throw a function, or will throw an exception. There are some functions that says, okay, I will get the value or I will return the null to you. So do it this way. The other thing is to fail fast. This idea of failing fast is quite common, but what I mean here is we can, Siri is not available, sorry. You don't see it, sorry, it's on my computer. I don't know why Siri wants something from me right now. So basically, we have some integration layers with some Java libraries, with some, REST clients, with database, and they don't guarantee to us that we've got what we want. We want non-nullable types in our domain code. Why? Because in most cases, business doesn't think in nullable types. They want values there, and there are cases in which we have some nullable types because that's the business logic, right? But if we don't want them, we should fail fast. If some null is the result only because of some integration with some Java library, we should express it very fast in our code. And throwing an exception at the early stage is one of the solutions. And it will probably save your time when you try to debug and find out, okay, what's going on? Why do we have this null here in my domain code? Okay, let's go through the stack trace. And then you just lose, 15 minutes to know what's going on. But at the previous slide, you've seen that I've created my kind of exception, some custom class. If you use these two exclamation marks in Kotlin, you're just using this, generic exception, which doesn't provide any information what's going on here, what's wrong. So don't do this unless it's test package and you're 100% sure that there won't be null, but the compiler just, says that you need to throw an exception or return a nullable type. So in test package, okay, but don't do this in your production code. And if you're not sure about how to write a code the Kotlin way. There's huge documentation and Kotlin documentation about it. If you argue with your teammates a lot about how to, should I use if statement or when expression or something like this, the Kotlin community already did all these discussions and all the conclusions are there. So go check it if you're curious. There's plenty of stuff. Let's go further. Builder. So builder in Java is probably one of the most used design patterns, and it solves the actual problem. The problem is that we have some class, we have some parameters, we have some fields of this class, and not all of them are required. So we want this instance of that class to be created in different configurations. So in Java, we've got this constructor and plenty of nulls in there because we don't want these not required fields to be set. The alternative to this is to create as many constructors as many we have the combinations of creating an object. But it's also, many lines of code, totally unnecessary because who needs so many constructors? And the other thing, even if you have so many constructors, you're not sure which parameter means what. You've got two types of string nullable. So which one are you setting right now? So the Java solution to this, not only Java solution, it's it's some contract that all the programmer community agreed upon, that there's need of a builder. In Java, you would do this. You would create a builder with all these fields which are mutable, and you will define functions which will set these fields to some values. And of course, you have build method, which will create these objects that we, at the end of the day, want to have from the builder. So what you've got API like this. You got builder initialization, and then you invoke methods to set things, and at the end you build it, and you got the mail instance. In Kotlin, you don't need to do it. Why? Because Kotlin has two features which makes the builder problem not existing at all. First of all, you've got this named params. So when you look at this, the last line of this code snippet, you can see that we know which parameter is set. We know that 2 will get the list of jan@novak.pl, right? Message will be hello, so everything is clear. We know what's going to be constructed. The other thing is default params, which we can set in the primary constructor. In Kotlin, we construct objects using primary constructor, and the init block method in which we can put validations. So there's no more problem that builder was meant to solve. The next design pattern, actually maybe not a design pattern itself, is pipe operator. You might wonder, whoa, is there pipe operator in Kotlin? No, there's not. But in Kotlin we have, for example, scope functions. I know it's not a pipe operator, but it helps us think in the same way as someone would think using pipe operator. So basically, there's a problem we're going to solve. We've got many functions, invocations nested into each other, and it's a mess. We don't want to, review such code. We don't want to read it because we don't know what's going on. It's hard to read. So we can split it. And that's how pipe operator in programming languages like Elixir works. With this difference that pipe operator doesn't need this argument that is passed from the last function, right? But it looks very similar. I know it's not the same, okay? It's a joke, they are not the same pictures. But basically, it looks very similar. And in Kotlin, using scope functions can help us write the better code, more understandable. And because it's multi-paradigm, we can use this power of functional thinking. So there's another thing that could be used to express ourselves in code in a more functional way. It's extension function. So basically what extension function is a function on some type, not only on a class, because you can define the extension function on a nullable type. So it's not on a class, it's on a type. And someone will say, whoa, this is breaking the class API because it's not object-oriented, and what are we doing here? And actually, what are we doing here is just creating a static function. So it's just a function. Kotlin is just, very smart here to make it look like it was a method of a class, but it's not. It's a function of a data structure. So that's how extension functions should be used. They shouldn't be used as alternative to member functions. It's a totally different thing. And as you can see here, it's just a function taking some type as a param. So using an extension function can be also dangerous, because when you don't make it private as default, it can be really painful to your API, because when you have so many methods on some class and you don't need it everywhere probably. What I've met during my experience working with Kotlin was that usually people create extension functions to get access to some very hidden under all these data structure, all these class hierarchy field, and they want to get to it just by one function invocation. So extension function can be, for example, useful there. It can be useful in such cases as you can see here, but usually try to make it private by default, not to make your API too verbose. The next one, factory function. So what's the problem we're going to solve? Basically, factory function is as alternative to constructors. So what's the problem with constructors? In Kotlin, we usually use this primary constructor. As you can see here, there's an example of my linked list. And creating an object using this constructor is very verbose. It's showing how this data structure works, and probably client doesn't need to know it. What client wants to do here is to create a list of 2 elements, and now he needs to invoke 2 constructors and know how it's going to be constructed. So, but constructor is also connected to the problem that constructor doesn't have name. So you cannot express more. You just can say, okay, there's a class and open brackets, and that's all. So if you have array list and you create an instance of array list using constructor, you pass 3 inside a constructor, and then what? What will be created? Array list with integer 3 inside, or array list of size 3? So that's not clear. I know that you know what will happen, right? Because we use these interfaces for many years. But constructors are, in most cases, the best fit, but in some cases, a factory function is needed. So in Kotlin, we have plenty of options. Companion object factory function, extension factory function, top-level factory function, fake constructors, and last but not least, methods on a factory class. So let's go through them. Companion object factory function. So basically, there's a companion object, and there's a factory function inside, and it's useful when you want to create factory functions like of, from, etc. Because as you can see here, now we know what's going to be created, right? Because there will be a my linked list instance, and the API is very simple. It's as simple as needed. So this is one of the way of creating factory function in Kotlin. The other way is using extension function, which I already introduced. So you can create extension function on any type. It can be interface. This way, as you can see, I create an extension function on a companion object of an interface. So the must-have here, if you don't have companion object in interface or a class, you cannot extend it. So quite common pattern in Kotlin open source libraries is to create just an empty companion object to make it available to be extended by other developers when using these libraries. So what we have here is a simple factory function create car, which encapsulates all the logic of creating a car, and it's much easier for us to just create a car. It can be useful, these extension factory functions, for example, in stubs in test, if we want to hide the logic of creating objects for testing. We don't need to see it when we just see the big picture of our test. We can hide it using a factory function. Top-level factory functions are probably one of the most used because they are just functions, public functions. Here is an example from Kotlin collections. And list of, map of, set of, they are used very commonly, right? So they are just functions that create instances of objects. Whoa, okay, we're back. And probably one of the most shocking and interesting here is fake constructor, because many of you use mutable list and list, which are functions, and think, okay, it's a constructor. But it cannot be a constructor because mutable list and list, they are interfaces. So what Kotlin community agreed upon is, okay, we have interfaces, we can construct somehow instances of these interfaces, and we cannot create constructor of interface. So what we can do, we can just create a function. And this function starts from the capital letter, and that's why it might be confusing for you. But this is a good pattern. Don't consider it as a bad pattern in Kotlin, because that's actually from the Kotlin collection. So if designers of Kotlin do it, then it's a good pattern, right? And the last one that I listed is method on a factory class. So it's just a factory class. We have some users factory, and this user factory creates objects, probably doing some calculations in that class, like incrementing this identifier. So no rocket science here. And the last thing about factory functions I wanted to show you is there's one gray pattern, something that's not actually officially bad pattern, but it's also not recommended. So it is operator function invoke as a fake constructor. Using companion object and using this operator overload, we can actually do the same as we did with the function. With this difference, as you can see here, that not only we have a constructor, which is fake because it's a function in a companion object, we also have this invoke function. And this is messy a little bit, right? Because what's invoke function? And so it changes the API of how we use constructors, because both constructor and fake constructor, which is a function that I showed you on mutable list, have this very simple reference to a constructor or this function. When we create an operator invoke fake constructor, then we have different one. So it's changing the API. I mean, you can do it, you can use it. Also, people in open source do it, but basically it's not recommended. There are other ways. So you can use the other way of creating a fake constructor, not actually this one. And the last of design patterns I wanted to show you is a decorator pattern. So let's consider a following example. We have a person data class, we have a person repository, so we've got an access to some resource. It's a mutable map right now, and we have two functions, operator function get, operator function set, and again, it's an example of overloads of operators in Kotlin. And I know that this might look weird, that we have this repository, and we can treat it as it was a map. And I don't say that you should do it, because it can be very confusing for colleagues in the team. I personally prefer to use simple old repository find by, repository save, but I just wanted to show you how you can get some fun using Kotlin by this, showing this decorator pattern. So what do we have here? We've got some basic implementation of personal repository. That's something that, let's say, business wanted us to implement. And the new requirement comes to us. And okay, so we say, okay, so what's the requirement? And they say, we'd like, there was research on the market, and it turns out that there's a specific group of users, and they want, for some reason, this get function to lock something. I don't know, name of this person or something like this. And we say, okay. So basically, you want two groups of users. One will use this default implementation, and the other will use this with this special feature. Okay, we can do it. It's simple, right? We can do this. This will work. We can just, create a subclass and override the method, add some, decorate it, and then invoke a base class, and it will work. But a few days later, after deploy, the same person, I don't know, PO, PM, Scrum Master, whoever it is, comes and say, okay, it was great, it worked great, users are extremely happy, they can see logs, nice. And what they want us now, it turns out that there's another group of users, and they want age validation. But these people with age validation, they don't want logging, so it needs to be separated somehow, but there are still third group of people with this default implementation. Okay, yeah, no problem. We can do it. Another subclass and adding some validation to this method, overriding it. Great, works perfectly. A few days later, the same person comes to us and say, okay, it turns out that these two separated groups have some subgroup, and they want both. They want logging and validations, but still there's a group that wants only logging and another group that wants only this validation. And we say, okay, yes, we can do this. There will be this weird class, must be logging, must be adult logging repository that duplicates the same code we already wrote in two other subclasses. And I could continue this story with new requirement, etc. And this monster class with this very strong name will come at the end, and nobody likes it. So the decorator pattern is going to solve this problem. And to understand how to solve it in Kotlin, we need to understand what's delegation in Kotlin. So let's consider that we have some base interface. We have some implementation of that base interface. And what we want right now, the second class here, derived, is type of base. And derived class doesn't want to implement this interface, because derived class knows that there is someone in company and he knows how to do it, and I don't need to do it. I can just, provide methods, and that's all. I will get the colleague to my team, and he will implement it. So that's basically it. We use by keyword to explicitly say that, okay, I will get the B, which is type of base, and I'm type of base, but this B will implement these methods, so I don't need to. And this is basically how delegation in Kotlin works. And to show you another example how it can be actually useful, so let's say that, okay, everybody knows what's solid, right? So this is it. We have some interface segregation. We have some implementations of these interfaces. And we have some gut class, right? It's not a pattern, not a good pattern, right? But we've got someone who likes to implement these interfaces, who wants to, provide producing and logging, both of them, but not necessarily implement them. And that's how we can separate these two components from each other, because now this implementation doesn't need to be in one place, because first of all, we have interface segregation, but it doesn't help us with this implementation. So using the delegation in Kotlin, we can just compose blocks, right? We can compose them using delegation in Kotlin. And how to use it in our problem with decorator. So let's go back to the personal repository. let's make it an interface, and the default implementation will be actually the implementation of this interface. And here, the implementation is the same as it was for this person repository before. So what we can do right now is to use delegation pattern in Kotlin. So we have this delegate passed to the primary constructor for both classes, because we have two features, right? We have two features, so we cannot avoid situation when we actually implement them. And what we do here is providing the default implementation of delegate by delegate to this subclass of person repository, but we override one of these methods. And as you can see, we do the stuff like logging, validation, and then we use the delegate method. So that's how we can decorate the behavior of a class. And why is it better? As you can see, we can construct all the combinations the more understandable way, because we can have this default repository. It can be some bin or whatever. Then we use this default repository. We're passing it to logging person repository. So this is now logging person repository. We have this logging feature for this property. And then we can use this logging person repository to create this weird one, must be added logging person repository, because passing it over and over as a parameter to another subclasses, we just combine these features with each other. So this is the decorator pattern in Kotlin. And yeah, it was actually quite fast. Maybe I was talking too fast, sorry guys. So summary to give some tips after this review of design patterns and going through through these fancy things in Kotlin, because I wasn't sure what type of presentation would be perfect, because there are plenty of stuff in Kotlin which I could have shown you here. This presentation was meant to be 40+ minutes, and it was a little bit faster. I don't know how I did it. So that's why I didn't put many things that are very useful in Kotlin, because I thought that I wouldn't make it in the time, but I'm surprised right now. So yeah, let's go through the summary. First of all, the nullable types. Use non-nullable as default. Just use this nullable type when it's necessary. It will really help you understand what's going on in the code. I know that probably many of you are, experienced in Java. Maybe we can ask you. I can ask you a question: How many of you right now write code in Kotlin, as in a company or something? Ah, okay. So that's a minority. So okay. So I suppose that rest of you are from Java and you don't write in Kotlin actually. Okay. Maybe I should have asked this question at the beginning of the presentation. Sorry. And the second tip: follow the official coding conventions, because we don't need to invent a wheel again. So some topics are already talked through with the team of Kotlin. And don't implement builder in Kotlin. I know that using Kotlin still, when we use Kotlin, we still probably use some Java libraries, but not every time, because Kotlin is multi-platform. So in open source, because I do some contributions from time to time, they don't like JVM libraries being in dependency in Gradle. They don't like it because you have a list in Kotlin, and this list is an interface for a reason, because list in JVM is different implementation than list in JavaScript. So Kotlin can be transpiled to JavaScript, and that's all the magic that Kotlin teams does. So if you implement builder in Kotlin, you do something very specific to the JVM, actually. There's the problem. I'm not familiar with JS. Maybe there's the problem too. I don't know. Sorry. But in Kotlin, if you don't use already existing builders from JVM, you don't need to implement your own. So the next one, consider factory function instead of constructors to make it more clear what's going on, to express ourselves better, because functions are more descriptive and easier to understand and less verbose than constructors in general, because in most cases constructor is good enough. And scope and extension functions can improve readability. So use them wisely. You can go to the documentation of Kotlin if you're not sure which scope function should be used in which scenario. They explain it really well. For example, if apply or run is better, you can read them. I didn't go deeply through it because I could go deeply through each feature in Kotlin, and then probably I wouldn't have any design pattern on the presentation. So yeah, that's why I didn't do it. And the last thing here, delegation instead of inheritance. Consider it in cases in which you have many features, because at the very beginning of the project, we are not sure which is the direction. Probably even the manager doesn't know. So if you implement something that is hard to change, hard to compose components, then it will be hard to implement new features and the manager will be angry. So if we write a code which is easy to delete or easy to extend, then it's good. Because we can always, if it's easy to delete, write a new one and it will be fast, or extend it if it's extendable. So that's it. Thank you very much. If you'd like to catch me on some social media, feel free to do it. Especially, I invite you to the Medium, where I already written articles about server-side, mostly about Hibernate, if you're interested. So yeah, and there will be probably some new more about Kotlin in the future. And if you have any questions,